Part 1. NAC wiring methods. First off, we'll talk about the two NAC wiring methods. The first is known as a Class B circuit. A Class B circuit uses an end-of-line resistor, also known as EOL for short. This cable goes in and out of the NAC devices on its circuit until it reaches the last device, which is considered the end-of-line NAC device, because this is where the end-of-line resistor gets landed. The last device on this type of NAC circuit is the only device that needs an end-of-line resistor. To see how that resistor gets landed, let's take a look at this fire panel with one NAC device on its Class B circuit. Here we see how that resistor gets landed. With the NAC wire, the resistor goes across the positive and negative terminals of the NAC device. Even if there's more than one device on the circuit, the last device is terminated like this with a resistor. Why put a resistor here? What's the purpose of the resistor? The end-of-line resistor serves the purpose of circuit integrity. The panel is continuously monitoring for this resistor value. If there is an open or a short in the circuit, the panel knows to beep and display a trouble message, indicating there is an issue with the circuit. The panel will only be happy and normal if it can see the resistance value of the end-of-line resistor. That's a Class B NAC circuit in a nutshell. This is a Class A NAC circuit. This differs from the Class B circuit in a couple of ways. 1. No end-of-line resistor. 2. The last NAC device will have a wire loop incoming from the previous NAC device and outgoing straight back to the main fire alarm control panel. Without going into too much detail, we can see that a Class A circuit uses more cable than a Class B circuit would. However, it is more reliable and resilient in terms of circuit integrity. A short, ground fault, open circuit, faulty device, or cut wire will only stop the operation of the NAC devices up until that point. This is because, in the event of those issues, the voltage from the fire panel is fed into both directions of the NAC circuit.